Hello there. Today I'm going to present an interesting puzzle, some would even say a stunning puzzle, that is very easy to understand but hard to solve for generic cases. This puzzle is the Mondrian puzzle, and in order to explain the puzzle, I will have to go back in history and talk a little bit about Mondrian, who he was, and uh, and why he was influential. Perhaps mainly because it's an opportunity for me to link abstract visual arts with mathematics. It's always nice to be able to link subjects that are apparently unconnected. Mondrian was a Dutch painter, and his full name was Pietr Mondrian. But if you search on Google, you'll most probably land on Pietr Mondrian. And the Dutch version of his name is Pietr Cornelis Mondrian. So I don't know how this is pronounced, but I'm sure if you are Dutch, you would know. Let's check out the ideas that that he brought to the table as an artist, because I think it's quite interesting, because they are the foundation of many other movements that followed afterwards. He was known as the founder of neoplasticism. It's a bit strange to find the word plastic when we are talking about art, at least for me. I'm not an art expert, but I came to read that in the old days, plastic arts was used to describe literature and painting. So that's how the term neoplasticism arose, because it's like new plastic arts. I think Mondrian was trying to innovate this space, and and once he did that, people maybe gave this name to his movement, neoplasticism. So let's look at his founding ideas or principles. And I'm just reading what he wrote. So he says, I construct lines and color combinations on a flat surface in order to express general beauty with the utmost awareness. We'll find this word awareness often in his writings, almost as much as we find today in New Age writing. So he says, nature, or that which I see, inspires me, puts me, as with any painter, in an emotional state, so that an urge comes about to make something, but I want to come as close as possible to the truth and abstract everything from that until I reach the foundation of things. So he's attempting to peel off layers of illusion from an object in order to reach its essence or its underlying reality. Okay, so you can see that there is a search for truth. From that perspective, it's kind of interesting, because traditionally we think of abstract art as art which is kind of divorced from anything that's real. It's more like abstract, and it's about trying to represent maybe objects and things and feelings that probably may not even exist in reality. So it's not, I think he was trying to explore the idea that art is not only for representational purposes. And he's not only the only one who had this inclination. I mean, most of his peers were also trying to do the same thing. But what struck me in all his writing again is his frequent use of the word awareness and intuition, for example. So he says, I believe it is possible that through horizontal and vertical lines constructed with awareness, but not with calculation. So it's not like you're drawing a building and trying to adhere to perspective laws and make sure that the rules are respected. But he's drawing with awareness led by high intuition. So that's kind of very interesting to me, because it's almost as if he's trying to sit in meditation, to still himself and to become aware and to let his intuitive feelings manifest and try to capture that. And we can also see that he wants to represent more subtle things like harmony, rhythm. And those are really aspects which are more difficult to represent in the visual medium, but that we know exist. Definitely. We can't deny their existence. So just to maintain the flow, I will read the full thing. I believe it is possible that through horizontal and vertical lines constructed with awareness, but not with calculation, led by high intuition and brought to harmony and rhythm, these basic forms of beauty, supplemented if necessary by other direct lines or curves, can become a work of art as strong as it is true. Okay, he's not talking about the visual art that's going to be produced as something that exists on its own as a beautiful object, or not even beautiful, doesn't need to be beautiful, but as an interesting object, a noteworthy object, as many other modern artists have tried to do. But he does believe that it is connected to some deeper reality. Okay, so that's, I think, one of the main differences between Mondrian and the other more abstract artists. He was convinced that he's trying to represent the underlying reality of things, and his minimal use of lines and colors and spaces also put him as one of the pioneers of minimalism. And he was also influential, an influential figure to the Bauhaus movement that came afterwards. So in that way, he was a big influence in the art world. And if you look at his trajectory as a painter, and you look at his earlier paintings, again it was very, very representational. So that's the painting of a church in 1898. And then over the years he started focusing more on rhythm, harmony, and balance, and as I said, more subtle issues about the world that needs representation. So this tree, for example, It's just trying to show the flow of the branches and how they stand together. So that's quite interesting in that sense. And then towards the later stages of the career, he dropped curves altogether, and he was only focusing on straight vertical lines and horizontal lines and large areas of color. So that's what Mondrian was about. And now we come back to the Mondrian puzzle. Okay. So in order to describe this puzzle, let me just show you that this little grid here. Let us say you have a canvas, and this canvas has, in this case, it has like 6 horizontal squares and 6 vertical, and there are actually 36 squares in this canvas, and you are asked to color those squares according to some rules. Okay, and these rules are here. Okay, these are the coloring rules. And the first rule is that the canvas must be entirely covered by non-overlapping rectangles. Okay, so that's very simple to understand. Okay, you want the whole canvas to be covered by rectangles, but make sure that none are overlapping. Then the second coloring rule is all the rectangle edge length must be whole numbers. So as we saw here, this rectangle is a 3 by 2, this one is a 2 by 2, and this one is a 1 by 6. All these dimensions are whole numbers, they are not fractional. And lastly, no two rectangles can have the same dimensions. So a 3 by 2 and a 2 by 3 rectangle are not both allowed, because if we do have it, then it would mean that one rectangle can be rotated and to produce the other one, and that's another rule to keep in mind. Okay, so if you apply these rules together to any kind of rectangles that you want to place on this canvas, you might end up with this example here. Okay, we have all the rectangles are different. Okay, so this is a 6 by 1. This is a no, this is a 1 by 6 rectangle. This one is a 5 by 1. This one is a 3 by 1. This one is a 3 by 2. And what is this one? This one is a 4 by 2. And this one is a 2 by 2 rectangle. And this one is a 1 by 3 rectangle. And the colors that we are using are primary colors. In art, the primary colors are kind of different from the primary colors in physics, suffice to know that primary colors only means basic colors that you can mix or blend or add to each other or subtract from each other in order to produce a range of other colors. Okay. For now, let us just assume that the colors that we are allowed are primary colors from an art perspective: red, yellow, blue, and white, and black, but black and red are not technically primary colors. Okay, but you could use these colors in your Mondrian puzzle. Okay, and then how to score each painting. each puzzle that you have produced, each painting has a score, okay? And you find that score by taking the rectangle, the area of the largest rectangle and minus the area of the smallest rectangle, and that would give you the score. So what is the largest rectangle here? So this one is like 4 by 2. This is 8. Okay. And what is the smallest rectangle? Here we have 1, 2, 3. Okay. So 8 minus 3 is 5. So that is the score of this canvas here. So every partition, every coloring that is according to the rules is going to produce a score. And that score is found by taking the largest area minus the smallest area. Okay, so it's easy to explain this puzzle, but if you were to try to solve it for a very large matrix, let's call it a matrix, a very large canvas, let's say n by n canvas, then you might reach a point where it's quite hard even to find that the score is that you would calculate is actually the minimum one, because there are so many different ways to to organize all these rectangles. And most of the solutions that are found are by brute force. So we are still looking for an algorithm, a series of steps that would allow us to determine, at least what's the minimum for an arbitrary canvas of dimension n. So this was about the Mondrian puzzle and how to solve it and why it's interesting. All right, so thanks for your attention.